So, dear students, Assalamu alaikum. In this video, we will discuss about inductance. As you know, inductance is something like the resistance and capacitance. We have a study about the inductance. Okay. And the symbol of the inductance is given like this. As you know, the symbol looks like this. This is what an inductance is, and it is denoted by the symbol L. Okay. So normally what an inductance is, you have a coil, a core, some core material. It may be made using metal or dielectric, whatever it is, and you have the windings, some wire windings around the coil, around the core. This is what makes an inductance normally. Okay, you wind some wire around the coil to get the inductance. Okay, these are the two terminals of the inductance. Okay, so this is the core, and this is the winding with N turns. Okay, N turns. Okay, N turns around the core. You will wind around the core and N turns to make the winding. Okay. So actually what happens is, see, the action of an inductance is like this. When you move the coil, okay, when you move the coil in a magnetic field, okay, when you move this particular coil in a magnetic field, okay, or else if the magnetic field changes, if the coil is not moving, but the magnetic field is changing with respect to the coil, then a current will be produced in the coil. Okay, so you can say current produced in the coil when the coil moves in a magnetic field or magnetic field varies. Okay. Changes, that is changes. Varies means changes with respect to the coil. Okay. So either the field should change with respect to the coil, or else the coil should move in a constant field. Okay. Then you have a current induced. So this current is called the induced current. In an inductor you have an induced current. Okay. Induced current. Okay. So there is a relation between the voltage and the current of an inductor that we will examine in the next slide. Okay. Suppose if you have an inductance like this. Okay. This inductance is L, right? And you have voltage VL. Okay. And a current flowing into the inductance given by IL. Okay. The relation between the voltage and current is given by VL equal to L L d IL by dt. This is the law for finding out the voltage across the inductance. So you have a voltage induced in the coil when you have an induced voltage. Okay, voltage induced in the coil. Okay, induced voltage. When there is a change of current. If there is no change in current, dIL by dt will be 0. So there will not be any voltage induced in the coil. Okay. So regarding the convention, you see, if you have a coil like this, okay, and the voltage is like this, VL, right, and suppose if you have a current IL going inside like this, okay. So when the current is flowing in, the current IL is positive. When it flows into the positive side of the voltage of the inductor. Okay. So the inductor dissipates power. You can say the inductor dissipates power. Okay. Similarly, and IL is negative, right? When it flows out of the positive side, right? And you can say that inductor, you can say that the inductor releases energy. Okay. So current is positive and it flows into the positive side of the voltage of the inductor as is shown in the figure. So the current is flowing out from the positive terminal, you can say that the current is negative and the inductor is releasing energy. Okay, that's how you will have the thing. Now we will do a very small example problem. Okay, example 1. What is the inductance? Question is, what is the inductance if 37 millivolt is induced across a coil if the current is changing, at a rate of 68 milliamperes per second. Right? We have to find out the answer. Okay. See, we have the formula. What you are asked to find out? You are asked to find out the inductance. You are given the voltage and the rate of current, right? Rate of change of current. Okay. So you have the formula VL equal to L dIL by dt. Right. you have VL equal to 37 into 10 raised to minus 3 volts, right? And the rate of change of current is given. The rate of change of current is DIL by dt, right? And DIL by dt is given as 680 into 10 raised to minus 3 amperes per second, right? So you are asked to find out what is L. So you say L equal to VL divided by DIL by dt, isn't it? So this will be 37 divided by 680, because 10 raised to minus 7, 10 raised to minus 3 cancel. So you will get it as 54 into 10 raised to minus 3 Henry. Henry is the unit of inductance. Henry. Okay, Henry. This is the wahda, the unit for the inductance. Okay. So you can say L equal to 54 milli Henry. That's the answer, right? So that's how you will find out the inductance when you are given the rate of change of current and the voltage. Okay. Now we will do another second problem. We will do example 2. Question is the independent current source shown in figure generates zero current. You can say it is zero current for t less than 0 and a pulse of 10t e raised to minus 5t amperes for t greater than 0, right? So the circuit is given. The circuit is given like this. You have the circuit like this. Okay. You have an inductance like this. So this is a current source and inductance. You have 100 millihenry. So this is plus or minus V. This is I, right? Okay. And what you are asked to find out? Determine. You are asked to find out, determine A, that is voltage, V. Okay. B, that is, no, nothing is there, only voltage. So what is the voltage answer? Suppose we are writing the answer. You can write the answer like this. What is the voltage? Determine the voltage given the current at the terminal of the circuit, right? You know the voltage V equal to L di by dt, isn't it? So you know what is L. L is 100 milliampere. Di by dt you have to find out. So you can see that di by dt you can find out by doing the integration. By parts you can say it is like it will be di by dt equal to di by dt equal to, first you will do the integration differentiation for the t, then you will get a 10 e raised to minus 5t, right? Then you will do the differentiation for the other part, then minus 50 t e raised to minus 5t, right? So this is a okay. So we can see that if you multiply it with L, you can find V equal to find out V equal to 100 milliampere Henry, right? 100 milliampere Henry is 0.1 Henry, right? Okay, you can write it as 0.1 Henry into 10 raised to minus 5t minus 50t e raised to minus 5t. So you can write the answer on the next slide. So it can be written as V equal to 0.1, right, into 10 e raised to minus 5t, right, minus 50t e raised to minus 5t, right. It will be e raised to minus 5t minus 5t e raised to minus 5t when t greater than 0. T is less than 0, you can see that it is 0, right? Because I equal to 0, di by dt will be 0. Okay, and 0 when t is less than 0. That's the answer. Okay. Now we will see some more relations. See, we have the equation. Okay, we have the equation. We have the equation VL equal to L DIL by dt, right? Isn't it? From that, you can see that you can write VL dt equal to L DIL, right? Isn't it? So what is you can write 1 by L integral 1 by L VL dt equal to DIL, right? So if you want to find out IL, okay. Now if you want to find out IL, you have to integrate both sides, right? If you integrate DIL, you will get IL. It will be from 1 by L, you can take outside some initial time t0 to t, right, VL dt plus an initial current I t0, right. So this is the formula for finding out the current in an inductance when you are given the voltage across the inductance and initial current is, you can find out the current at any time t, ILT, you can say it is a time t, right. So we'll do some problem, then it will be very easy for you to understand. Okay, time t0, if t0 is 0, okay, if t0 is 0, simply you have to find out this thing, okay, when t0 equal to 0, when t0 equal to 0 second, okay, and you can write ILT equal to 1 by L integral 0 to t VL dt plus I at time 0, some initial current at the time 0, okay. So now we will try to find out something for a problem. We'll do a problem for this thing. We'll do an example 3. So you have a circuit like this. See, you have voltage source here, V1 by V, and then you have an inductance of 100 millihenry. Okay, then there is a current I flowing through this, which is given by I. Okay, and you are given V equal to 0 for t less than 0, V equal to 20t e raised to minus 10t volt for t greater than 0. Right. Now, what you are asked to find out is find the current. Find the current in the inductor. Okay, the current in the inductor. That's what you're supposed to find out. Also assume I equal to 0 for t less than or equal to 0. Right. So the answer for this you can write. You can write the answer. Right. What's the formula? The formula is like this, isn't it? You have the formula like this: IT equal to 1 by L integral 0 to t, because t0 equal to 0 here in this case, right? V d tau plus I0. Okay, but you are given I0 equal to 0, right? I equal to 0 for t less than or equal to 0, right? Because of that I0 equal to 0, because of this condition. Okay, because of this condition. So now we can write this thing as IL equal to, because of that we can write IL equal to 1 by L integral 0 to t VL dt, right? Now you know VL is, so this is equal to 1 by L is 1 by 100 millihenry, right? This is 1 by 100 into 10 raised to minus 3, right? Millihenry, right? Integral 0 to t 20t e raised to minus 10 t dt, right? That's how you have the thing. Now 20t e raised to minus 10t, what I feel is we can use the equation for integration by parts, right? Suppose you have an integral uv dt. Suppose you have an integral uv dt, right? You can write it as u into integral v dt, right, minus integral of the differential of u dash, then integral v dt, right, close the bracket here, right, then dt, right. Okay, in this case what we can do is we can take one of these as u and the other as v, right? So what I do is I will take this thing as u equal to, okay, I can take u equal to, I will take it as anything you can take, 20t I will take it as u, right, and v you can take it as e raised to minus 10t, right? So then this integral becomes u is 20t, right? Integral e raised to minus 10t dt minus integral of u dash, that is 20, right? It is 20 integral, right? E raised to minus 10t dt, right? This will be 20t into e raised to minus 10t divided by minus 10, isn't it? Minus integral 20 e raised to minus 10t by minus 10 dt, right? Isn't it? So that is what is 20t e raised to minus 10t dt is given like this, isn't it? Now you can simplify it more. See, you can write it as 20 by minus 10 is minus 2, right? You can write it as equal to minus 2, right? See it? Minus 2 t raised to minus 10t, right? Minus 2 t raised to minus 10t, right? Again you go to the other side. Then minus and minus is plus. Then you can take that 10 outside, right? Minus 1 plus 1 by 10, right? Plus 0.1. Plus 20 plus 2 we can take outside, right? 20 by 10 minus 10 plus 2 plus integral right? That's it, right? 2 e raised to minus 10t dt, right? Now this is minus 2 e raised to minus 10t minus 2 by 10 e raised to minus 10t, right? So now you apply the interval over that 0 to t, right? So the first term, when this, you can say it is minus 2t e raised to minus 10t minus 1 by minus 0.2 e raised to minus 10t, right? That's the answer for the voltage. Okay, that's how you do the problem. This is for t greater than 0, and obviously for t less than 0, this is I IL, and IL equal to 0 for t less than 0. Okay, that's how you have it. Now we will see another important thing. It's called the power in the inductor. Power is, you also know, power equal to voltage into current, right? So you can write it as voltage is LdI by dt, right? So it can be written as Li di by dt. So this is equation for power. Okay. And if you don't know I, okay, you substitute I equal to, if I equal to integral 1 by L v dt, right? 0 to t, or t0 to t, right? And you can write power equal to V into 1 by L integral t0 to t, t0 to t V to plus I t0. That's how you will find out the power. And power is having another equation also. See, power is the rate of change of energy, right? Energy or work. That's what is power, right? So power is dW by dt, where W is energy stored, right? Isn't it? And if you substitute both things, you can find out W equal to half of L I square. That's an important equation for the power. Energy, right? Energy, right? So that's the energy stored in an inductance when it is charged by a current I, right? Now we'll do a small example. Right. In the next slide we'll do a small example. Suppose you have an inductance of L equal to 0.1 Henry, right? The current through the inductance is, the current in the inductor is IT equal to 10t e raised to minus 5t ampere, right? Find the voltage across the inductance. Question is, find voltage across the inductor. That's the first question, right? So what's the voltage across the inductor? V equal to, you know, the voltage is given by V equal to L di by dt, right? So that will be 0.1 into di by dt, that is, you can find it as 10 e raised to minus 5t, right? Minus 50 t e raised to minus 5t, e raised to minus 5t. That's the current voltage, right? Energy, what is the energy? Energy is given by W, right? Energy is given by find the energy stored in. You can find out the energy W equal to, what's the equation for the energy? Energy is given by half Li square, right? Half Li square, half that is 0.1 divided by 2, okay, into I square. I square is 10 t e raised to minus 5t square, right? So this is 0.1, you can multiply by 1, so it will be 0.1 by 2 into 100 t square e raised to minus 10t. It will be 5t square e raised to minus 10t joules. That's energy stored. Joules is the energy stored. That's how you find out the energy stored in the inductance. So we will do another example also. Example 5. We have example 5. Find, question is, find the current through a 5 Henry inductor. Through a 5 Henry inductor if the voltage across it is given by Vt equal to 30t square for t greater than 0 and 0 for t less than 0. Okay. So the current is given by the current is given by I equal to 1 by L. And for the current I equal to 1 by L. It is given by I equal to 1 by L integral 0 to t VL dt, right? So you have that will be equal to 1 by 5 integral 0 to t 30 t square dt, that is 1 by 5 into 30 t cubed by 3, 0 to t, right? So it will be 1 by 15, 30, that is 2 t cubed ampere for t greater than 0, 0 for t less than 0. That's how you find out the answer for that question. And also you are asked to find out the energy stored. Another part of the question is find energy stored within 0 less than t less than 5 seconds. Okay. Assume, or also asked to assume I0 equal to 0. Right. What's the equation for the energy stored? So the energy stored in an inductance actually is given by, okay, energy stored is given by half Li square, right? But Li square means here you have to do the integration, right? You have to do the integration, then only you will be able to find out the energy stored, right? So you can find out the integration for the energy stored. Okay. You have dW, right? You have dW equal to P dt, right? So energy stored equal to integral P dt, right? And what is P? P is and also you can find it out as P is L di by Li di by dt, right? So Li di by dt. So you can write integral. This can be written as like this: L I d I, right? That's how you can write it. Sorry, Li di also. Li di also you can write. So it's better that you use the integral P dt function. That would be better, right? So what is P? P is Li di by dt, right? So what is di by dt? We have found out the current, right? Current we have found out as what's the current that we have found out? Current is 2t cubed, right? The current is 2t cubed. So you can write it as P equal to L into 2t cubed into di by dt. In differentiate 2t cubed by 3. Okay. Then you will have 2 again, t cubed by 3. You will have 3 t square, right? So it will be 4L, right? Then 2 into 2, 4 into L, 4L. No, it's not 4L. 2 into 2, 4 into 3 is 12. You can write as 12L t raised to 5 watts, isn't it? Now if you integrate it, you will get a power. Okay, power equal to integral 0 to 5, right? That is the integral that you have to find out. 0 to 5, then 12L t raised to 5, right? 12L t raised to 5 dt, right? So that will be 12L t raised to 6 by 6 joules. What is L? L is 5, that is 60 t raised to 6 by 6 equal to 10 t raised to 6. Okay, 10 t raised to 6 in the interval 0 to 5, right? So you can write it as 10 into 5 raised to 6. How much is it? Find out what is 10 into 5 raised to 6. Can find it out. 10 into 5 raised to 6. 10 into 5 raised to 6 equal to 156250. 156250 joules. That's the energy in this particular equation. Understand? Now we will do one more problem. Okay. Or else I will stop here. I will make another lecture and show you. That would be better.